Alright students, in this video I'll be covering problem number 4 from the test 2 review. This problem is all about imaginary numbers. You're asked to simplify the following complex numbers and make sure you show all your work. So if you take a look at A, what you should notice is that you've got basically like a linear, a quadratic, and a constant term. Things we should know about complex numbers, of course, are that let me think where I can write all this. Things we should know. We should know I squared, I cubed, and I to the fourth. And remember I taught you that you do I1. But make sure the 2 in the center are negative. And that also that after a power of 4, for the fifth power it repeats and is the same as I to the first, and I to the sixth repeats and is the same as I to the second, and so on. So if we divide our exponent by 4, then we compare the decimal value, the remainder, to these values to see what they equate to. And 0.00 meaning it divides evenly. So I told you to think 25 cent, 50 cent, 75 cent, $1. And that means it divides evenly. So if we take a look at 4a and how this can help us, we should see that we can replace I squared here with -1. So that means I'll have negative 8i minus 4 times -1 in place of I squared plus 2. Well, this can be multiplied together, so that gives us positive 4 plus 2. And of course at that point we've got two integers here that can be combined. One thing we always want to also remember is that we should always write our numbers in the form a plus bi, where a and b are the real parts, but bi is your imaginary number, so leave that after your real part. So why is that important? So for A, when you write your answer, 4 plus 2 is 6, but make sure you write it, the final answer, as 6 minus 8i. So 6 minus 8i would be how I expect to see your answer. Next we have I to the 311th power. So remember I told you to take 311, divide by 4. So on your calculator here, 311 divided by 4 ends in a number that's 0.75. That means it equates here to I cubed, which is -I. So that means this has the same value as I cubed, which is -I, and that's your answer. Next, notice for C, your operation here is subtraction. Remember, just like when subtracting polynomials, you do not change the signs of the first quantity here, this first polynomial, but subtracting means you're subtracting a positive 7 and a positive I, which means I told you to think of changing the sign to plus and changing the signs of the terms after, kind of like distributing a negative. So this makes it -7 minus I. Well, these parentheses here are really unnecessary at this point, so I'm just going to combine. Actually, I'm going to rewrite it so that I have 4 minus 7 minus 3i minus I. So my like terms are next to one another. So I can combine these integers here and these I terms. Remembering that if I don't see a number, it does have a coefficient of -1. So 4 minus 7 is -3. And -3i minus 1i is -4i. So that's what we should get. So just think 4 minus 7 is -3. -3i minus I is -4i. Next for part D, you're dividing. So remember we want to rationalize. So to rationalize, I taught you that if you're dividing by an imaginary number that's just a monomial, you can just use I over I. And that on the bottom would give us 6i squared. What we should remember, however, is that I squared is -1, so this will actually turn out to be -6 as our denominator. Then up top, we need to, when we multiply by I, distribute. So that'll give me 2i minus 7i squared. Well, remember that I squared is really -1. So that'll give us 2i plus 7, because -7 times -1 is +7. I also shared with you that if you're dividing by a negative, to make sure that you change the sign so that you don't have a negative in your denominator. So what I'm going to do is change this 6 to a positive, 2i to a negative, and the plus 7 to a negative. But I'm going to rewrite it so that my real number is first, then my imaginary number. So negative 7 minus 2i over positive 6 is my final answer. All right, for E, you want to remember that you need to multiply by the conjugate. Remember that conjugate is not opposite. For A plus BI, the conjugate is A minus BI, so we're just changing the operator. So 2 minus 5i is what I'm going to multiply by, but this is multiplying by a convenient 1. This quantity divided by itself equals 1, so we're not really changing its value, we're just manipulating it. So in my numerator, I just want to distribute, so that gives me negative 14 plus 35i. While in the denominator, if I'm multiplying, I'll do it down here on this paper, 2, let's see, so this is what I'm multiplying now, 2 plus 5i times 2 minus 5i. We're going to get terms that cancel out. So my I terms cancel out. Remember that I squared is negative 1, so it's going to turn into positive 25. And I just need to combine my integers here. 4 plus 25 is 29. And if I do not have a common factor to reduce, then I'm through. So it's not too bad. Just remember, conjugate, distribute on top, multiply on the bottom, but your middle terms do cancel out. All right, so last one on this page for F, you've got the opposite of the square root of negative 500, e to the 4th, f to the 7th, g. Because our index is 2, things we should remember. If we ever take the square root of a negative number, it's just going to equal I. Well, remember, if you have the square root of negative 500, that's really the square root of negative 1 times 500. So we can take the square root of this part out as I, but then the square root of 500 has to be simplified. So if I simplify the square root of 500, if I just use 5 and 100, I can stop there because the factor of 100 is a perfect square. In fact, the square root of 100 is 10. So I'm going to put a 10 out here. What's left is 5, so I'm just going to have 10 and 5. But I do have to also consider my variables. If I have 1, 2, 3, 4 E's, 7 F's, and 1 G, and I'm finding the square root, then my job is to look for pairs of factors. Because I can form two pairs, that means in my answer, I need E squared. If I were to have any E's remaining, it would remain under the radical. For my F's, I have 1, 2, 3 pairs, so I need F cubed in my answer. The F that's remaining goes under the radical. This G doesn't have another G to pair up with, so it also remains under the radical. The only thing I need to consider here is that there was already a negative, and I should have my I. So my answer here would be negative 10 E squared F cubed I square roots of 5FG. Alright, so this negative is because this negative is already out here, and the I comes from the negative on the inside. Other than that, it's just simplifying a square root. Alright, so I'm going to flip now to the back page. Let's see. Alright, so if I pick up back here with G, this is similar to the one we did in the warm-up in class, the exercise in class, and the exit. So we've got 4 numbers and they're all being subtracted. So I'm going to put blank minus blank minus blank minus blank, and then find the value of each of these individually by dividing my exponent by 4. So 32 divided by 4 it divides evenly, so I'm going to put 0.00. 30 divided by 4 ends in 0.5. It's kind of like an infinity. So 0.50 or 0.5. 36 divided by 4 does divide evenly, and 46 divided by 4 ends in 0.5. So my job now is to go back to that eye chart and then fill in what all these equal. So if it divided evenly, it's equal to 1. If I got 0.5, it equates to I squared, which is -1. Again, 0, 0, that's 1, divided evenly, and then -1. So the tough part is making sure you don't mess up with any signs, but if you want, don't make it hard. Just do 1 minus -1 minus 1 minus -1, just like we did on paper, and it'll come out to equal 2, and that's your answer. So, of course, we could change minus and negative to plus, and you'd have 1 plus 1 is 2, and so on. But you can also use your calculator. So for h, remember that this is repeated multiplication. So this is 4i cubed 3 times. So 4 times 4 times 4 is 64. And we have I to the 9th power. Just think, my rules for exponents say that if I have a power raised to a power, I multiply exponents. But if you were to expand all of them, you would see that you had 9 i's total. But of course, no answer at all for these problems should be left with an I with a power higher than 1. So if I have 9 here, I'm going to do 9 divided by 4, and I get 0.25. So that 0.25, if I look back here on my chart, 0.25, that's just equal to I. So this is going to be equal to 64 times I, because I to the 9th is the same as I. So my answer is just 64I. Next for J, it's just a matter of distributing. So this gives us 15I minus 24I squared. But of course we should remember that I squared is -1. So this ends up being 15I minus 24 times -1. So think of this as -24 times -1, making it positive 24. But again, we always write the real number part first. 24 plus 15i would be the correct answer. Now h is going to require a little bit more room, so I'm going to do this on my paper here. So remember, exponents mean repeated multiplication. So I'm going to do 2 minus 5i and just do these in a box because I can. And fill them in. So this time they don't cancel out. So we end up with 4 minus 20i, because -10 minus 10, if you need to put that in your calculator, do that. -10 minus 10 is -20i. But do remember that this is 25 times -1, which is -25, because I squared is -1. So when we combine our terms, it's actually 4 minus 25, or -21 minus 20i. And to that, I'm going to add the product here. So this will be 9, 12i, 12i, and 16i squared. That gives me 9 plus 24i. Remember, 16 times -1 makes that minus 16. 9 minus 16 is 7. Excuse me, -7. So I'm going to have -7 plus 24i. At this point, I want to combine my like terms, so I have -21 plus -7. Put any of this in your calculator, you need to. Oh, I'm sorry, not I. So that's just -28. -20 plus 24 is positive 4i. So our answer is -28 plus 4i. Alright, next for I, this should be a little easier because you only have to multiply two binomials. but you're going to double distribute, so feel free to use the box if you like. So 12, 10i, negative 42i, and negative 35i squared. That'll give us 12 minus 32i plus 35. Hopefully you're recognizing that by now. Negative 35 times negative 1 is where we get the plus 35. Add these two terms together, and that'll give us 47 minus 32i. And that concludes problem 4 with complex numbers.